Section 3.6 in your book is on specific heat. So now that we've done the lab on specific heat, this should be a little bit easier and probably make a lot more sense once we go through this video. So again, the definition of specific heat is the amount of heat needed to raise the temperature of 1 gram of substance by exactly 1 degree Celsius. So we now know that heat is thermal energy and it is a type of energy. So the formula for specific heat is heat divided by mass times delta T. Okay, and delta T equals change in temperature. Okay, the units for specific heat are either calories, that's the lowercase c calories, per gram degrees Celsius, or joules per gram degrees Celsius. You will mostly see specific heat listed in joules per gram degrees C. Okay, there's a table in your book on page 80 that lists the specific heat for different types of substances. There's just a few listed, but sometimes problems might ask you to calculate the heat required by something to either raise or lower the temperature by a certain amount, and you might have to look up the specific heat for that substance. So keep that table marked in your book, so if you need to refer to it, you can. All right. So one thing that you will use a lot is the specific heat for water. So the specific heat for water in calories is 1.0 calories per gram degree C, and in joules it is 4.184 joules per gram degree C. We used both of those in lab last week. So one thing that's important is in order to calculate specific heat, you need to know how much heat you've used or you've either lost or gained. So the formula or the equation for heat is written here. So heat is equal to mass times the change in temperature times specific heat. So if they want you to calculate heat in calories, then this is how the units work out. So mass is grams, temperature is degrees C, so these little dots in between just mean times, and then you would use the specific heat in calories per gram degrees Celsius. Okay, so if we look at our units, we have grams and degrees C multiplied in our numerator, so these cancel because we have both units in our denominator. So we are left with calories. So calories equals calories. So check. That's how our units work out. If we need to get the heat in joules, then it's very similar. So grams times degrees C times our units for specific heat in joules are joules per gram degrees C. Okay, again, grams and degrees C are going to cancel since we have them in the numerator and the denominator, so we are left with joules. Okay, so now let's look at one example. How many kilocalories are lost when 560 grams of water cools from 67 degrees Celsius to 22 degrees Celsius? So here is what we have. So we are given the mass of water equals 560 grams Okay, water is being cooled from 67 to 22. So they're giving us our delta T. So 67 degrees C minus 22 degrees C, because it started at 67 and we ended at a final temperature of 22. So if we do the math there, we would get 45 degrees C, and these sig figs are correct because if we look, we have 0 decimal places for 67 and 0 decimal places for 22. So our answer should also not have any decimal places. Okay, so delta T equals 45. So these are the two numbers that were given. They want us to calculate how many kilocalories are lost. So we are actually looking for the heat that is lost. Okay, so that's important. We're looking for heat, not specific heat. So the formula for heat that we would need to use is heat equals mass times delta T times specific heat. Okay, and the specific heat for water in calories is 1.00 grams, I'm sorry, 1.00 calories per gram degree C. So we only have specific heat in calories or joules. We don't have a kilocalories value. So we're going to end up having to convert once we get our heat in calories. So let's go ahead and get our heat in calories. So our mass of water is 560 grams. Okay, we plug that in. Our delta T is 45 degrees C. And our specific heat of water is 1.00 calories per gram degree C. Okay, so again, our units work out because we can cancel the grams and the degree C, so we're left with calories. If we do the math, we get 25,200 calories, lowercase calories. Okay, so our significant figures here would be 2, because 560 has 2 sig figs, and so does 45. The specific heat is an exact number. So I'm going to mark the 5, but I'm not going to convert in order to get the sig figs yet, because if we need to convert to kilocalories. Okay, so just keep track of your sig figs, and we're going to go ahead and convert. So there is 1,000 calories, lowercase calories, for every 1 kilocalorie. Okay, so we have calories in our numerator and calories in our denominator, so those cancel. Where did the pen go? Okay, so if we divide 25,200 by 1,000, we get 25.2 kilocalories. Okay, but we only need 2 sig figs in our answer, so we would round to 25 kilocalories. Okay, so the number of kilocalories that are lost when 560 grams of water cools from 67 to 22 degrees Celsius is 25 kilocalories. So what I'm going to do for this section, I know that it's a little tough. I'm going to post some practice problems, especially for this section. I mean, I'll post practice problems for the whole chapter. But if you guys will do those, I will also post a video um, going through some of those practice problems to make sure that you guys really understand. But I won't do that until later in the week.